As most of you already know, Kaplan Test Prep offers preparation for over 90 standardized tests like GMAT, GRE, MCAT, and other professional exams, example like a nursing exam or a bar exam. Our entire platform is designed and targets online education. Kaplan Test Prep, like other large businesses, has successfully transitioned from a primarily brick and mortar business to a digital-first business with microservices at the core. So our initial business challenges were reduced time to market for new products and features, and reduce IT infrastructure and operational costs, improve reliability and scalability of our core applications, and also improve engineers' overall satisfaction and level of happiness. We had some architectural challenges also. We had large systems to service ratio, more system equals to more operational overhead, and manual release processes, no CI, CDs, and complex scripts to maintain. Legacy monolithic application and web services needed to be transformed into infrastructure as a code and re-architected along the way. Previous state of our infrastructure was complex AWS EC2 server farms maintained manually. Code deployments involved 4 people and took more than 2 hours on average, and high infrastructure maintenance that require a lot of work. And we looked at different platforms out there. We looked at Apache Mesos, we looked at Kubernetes, and our decision was to build our own orchestration service in-house. And our platform is called SSDR, which is a 3-tier service scheduling, discovery, and routing platform comprised of 3-node of Consul server cluster. Consul is a product from HashiCorp, which is a key value store, and AWS EC2 container services, and as a front-end, Nginx routing cluster. Each tier fully usage auto-scaling groups and is independent to each other, so it scales automatically and horizontally, and it scales down also. And then the reason of the why of the SSDR was there was a need of orchestration which would fit our needs, and also is based on CloudFormation capabilities. As you guys are aware, you can build like a JSON template and send it to CloudFormation. And CloudFormation allows you to have properties which have attributes, so it's easy to query your state of your infrastructure at any time. Then Consul key value store, global state of the microservices. The reason of Consul was every time that a container comes alive, we want to save the state somewhere. And we are using Registrator, which is an open source service, that as soon as the service comes online, it registers itself in Consul. So if the service is on the back end on ECS is scaling out and scaling it, it will be added automatically to Consul, and it will be removed in base of load. And then at the end, Nginx for routing, customization, and proxying. We use Consul template to dynamically update our Nginx servers, and so to dynamically update our Nginx servers. And the reason of Nginx on the front end, of course, there is an AWS load balancer, was because we have personalized header and we needed a certain level of personalization, which in that specific case, AWS load balancer was not providing. And Nginx would do the work for us. Now, the SSDR key components, again, is based on CloudFormation. So we generate CloudFormation template, and then we call AWS API to build those templates for us. We use AWS EC2 container services. We used to use Docker Hub, and then we moved to ECR in this case for the reason because we can have control around our repos, we can apply policies, and we know what images are pushed around our environments. And then the container service that, as many of you guys know, is orchestration-based AWS service, which handles all the provisioning of containers and the orchestration of containers. Then the AWS identity and access management, we have a role when we push containers to our platform. Each application in this case is dedicated to a specific team. So in each team has a specific role when they provision the application. The AWS key management services, the challenge for us there was on encrypting and decrypting data that we are passing to container. So what we did in here, we leveraged the KMS to generate keys, private keys per team, and every time that the container starts during runtime or an application start during runtime, they can use to do an encryption, decryption through the AWS API. SSDR capabilities, so we flipped the ratio of system to services from 3 to 1 to 1 to 15. So one platform for QA, one platform for staging, and one platform for production. Code deployments now required one person and takes on average less than 5 minutes, and that depends on the AWS API on CloudFormation, but the average in our case has been around 2 minutes per application or per container on AWS. And we enable the self-service for developers to push code to QA stage and production. Our developers don't know how our infrastructure is designed, and we have a tool that will be introduced soon that takes care of making that abstraction from a YAML file to infrastructure as a code. And operational workload has diminished and improved the release cycles. The reason of that is SSDR being a 3-tier platform, Nginx, Consul, and ECS, it scales out and it scales down automatically as based on load. And on ECS, you can scale out based on your CPU credits. So every time that you are provisioning containers on your platform, if you allocate, let's say, a CPU of 200 and a memory of 300, the system automatically will see if there is enough CPU credits on the platform and will add more resources to it. And this happened automatically without any intervention from the operational side or from the engineering side. The current state of the infrastructure, so SSDR scales up and down based on usage demands. Again, the CPU reservations and CPU credits. And SSDR is manageable via code and has full audit capabilities. We use GitHub, so all our code is pushed and all PRs are approved before anything being pushed between QA, staging, and production. We don't have a dev environment because all our developers team are using containers and they're using Docker locally to test their containers. And once they're ready, we just push them to QA in this case, and once QA passes, push to staging and so on. And SSDR can be updated and maintained through push button deployments. We are a chef's shop, so I would say, and we have an imaging process for all the 3-tier, Consul, ECS, and Nginx, and we use RSpec and Cucumber to do our testing. Once an image is fully tested, is tagged with a version, which that version can be pushed to the SSDR. And as you guys know, the capabilities of autoscaling group is you push in a new image out there. If that image passes all the testing, it is successful. If it is not, it's going to roll back automatically. So this is something that is part of our platform, but of course has been provided by the autoscaling groups. And SSDR improves application security by separation. So in our case, we had a challenge because we had application that we wanted to be internal and application that wanted to be external, but we couldn't have 2 platforms, one for internal, one external. So what we did is our routing layer, Nginx, we divided it in 2 tiers, one internal and one external, and on front of them we attached an internal load balancer and external. All the backend on the ECS in this particular case, all the resources are shared. So an application, if it's internal or external, it doesn't really matter. It's just we do the segmentation on Nginx layer. So the SSDR is managed by the engineering team and is always there up and running and with all our CloudWatch alarm. And there was a need for our developers to come up with a tool which they could deploy, their containers or their services into in our case, on SSDR. So we created a tool. It's called udeploy, it's an internal name. So this doesn't have anything to do with udeploy, which is another tool out there. So udeploy acts as a translation layer between infrastructure as a code and SSDR, allows defining SSDR infrastructure using a declarative language, and uses the Ruby SDK to generate CloudFormation JSON templates. And udeploy is adaptable and flexible due to the dynamic nature of Ruby. Now, some of the udeploy features are YAML configuration file describing your microservice, easy adaptability of new AWS services. When I say new AWS services, as soon as the AWS service releases a new service, and of course is available for as a CloudFormation template, it's easy for us to get that template translated into Ruby code and allow developers to use that immediately. And then we have easy worldwide deployments to multiple regions, so we can deploy from region US East Coast or North California, and we just need to do just a switch of a region. And repeatability of your infrastructure, we can repeat this process n time, or we can reuse the same code, for the same, scope. This is a workflow about udeploy. So if I'm a developer and I want to deploy something on our SSDR platform, I don't want to know how our platform is designed. I don't also know how the infrastructure, including VPC, subnets, private, public, is designed on AWS. So when a developer comes to us and says, we want to deploy something to QA, they are free to do it at any time without any intervention from the operational side or engineering team. And all they have to do is fill out the YAML file definition, which requires certain information. And in this case, I'll be going over, let's say we have a meta definition which identifies the team name, the version, and the suite description, deployment. We support currently rolling deployments and blue and green deployments on the SSDR platform. We are looking on canary deployments. That will be a new feature on the next few weeks. And then if I go under, there is a definition for container. So in this case, my container is called Hello World, and it has an access. When I say access, I was talking earlier about internal and external routing. In here, I can define if my application needs to be internal to the corporate network or external to the network. And the developer has two options, internal or external, and then the Docker image. In this case, is a Hello World, and also the next part is a port. As you guys know, each container unit it has a port. For us, it doesn't really matter on what language or features that you are pushing inside your container. You are free to use inside of a container Ruby, Java, C++, any language that you are familiar. All we are interested about having a container, an image, and a port so we can take that container and push it out there for you. Then the next part is the Docker registry. So as I was mentioning, we're using ECR because we can apply policies and we want to keep track of all our images. And it was challenging for us to have everything on Docker Hub, so we moved everything into ECR. And then image tag. In this case, an image tag, when you push in an image, udeploy supports rolling updates or blue and green deployments. In that case, if you're doing a blue and green deployments, you'll be pushing two different versions or two different images with two different tags. And then every time you'll be calling our tool udeploy, and it will do the flip. There is an advantage there because when we do a blue-green deployment, a lot of people have challenges about TTL. In this case, there is no TTL, because what we do is the front door is just there is one load balancer. So when we are flipping, we're just taking those containers, they're registering them from the internal Nginx and moving it to the other one. So if there are users there, they'll go, all the new users, they'll come out automatically to the other load balancer. Or in this case, if you're flipping from blue and green, is the same. There is actually no DNS change. So the DNS is always one load balancer. And then we have a log var folder. This is to output all the logs on the container. This is an old implementation of it. We're not outputting any more logs. Log entry has an agent that you can deploy on your ECS infrastructure that can listen to the Docker socket, and every time a container is outputting anything on SSDR or SSD out, it will automatically be sent to log entry. So it was a big thing for us because we didn't have to keep logs locally or rotate logs. So in real time, every time when a container is pushed on our platform, the logs that are being outputted are being sent automatically to log entry. Then the next part is the platform. So right now we support Linux. We are working on supporting Windows on the next release of our SSDR platform. And then we have environment variables. The developer here is free to define as many environment variables as they want with their container. Then next part is the domain URLs. So what we did here is we didn't want, every time that we push a container, we didn't want to go and just create a DNS record on Route 53. So we are asking the developer here, what is the DNS name that you want? This DNS that is being inputted here, you deploy, once the container comes alive, only once it comes alive, it will go to Route 53 and say, can you create me a DNS record and point to a specific load balancer? And this happened automatically and transparently without any intervention or without any request or help desk ticket. The next part is there is a update DNS, which we give the opportunity developers to update the DNS record, always through the YAML file, and then force SSL. So I was mentioning Nginx. So as you guys know, on load balancer, you can attach one SSL cert per load balancer, but we have multiple domains. So in our case, we are terminating all the SSL on Nginx. So when it comes over, so we can leverage one load balancer. And the challenge there is, if you have 100 services, you have to have 100 load balancer, which is kind of expensive. Why not just using one load balancer as an entrance point, and then you terminate the SSL on Nginx? And that's the option to force SSL, so it will force SSL for the container. So if I'm a developer and I want to push a container and it needs to be HTTP, I can just say yes, true or false. Or if it wants to be, if we need to make it only HTTPS, then you'll put true. And then the resources. The resources part is very important, and we have this habit every time that we push containers to QA or staging or production. It's very important that we run load tests. Our platform, automatically leveraging placement strategies on ECS, scales out container based on load. So what happened here is, once you predefine the CPU and memory 100, 200, on the back end, when we set the placement strategies, we automatically scale the containers from at least 3 containers up to 12 containers. And we run some intensive load tests to see how this will perform. And what we notice is, it was all up to ECS. So when the containers will be hitting a certain CPU memory, ECS will kick in and will add more containers as it needed, and it will scale back. And it does this automatically without any intervention. If during the day we are, let's say we're having a test and we have 10,000 students, the system automatically will add the resources on the ECS layer because of the CPU reservation. And in here, it will see the containers that are reaching the max. In this case, it's a soft limit CPU, will add more containers automatically. And once the test is done, the system, in this case, the task scheduler on ECS, there's the concept of a service and task. So each task is a container. In this case, the ECS will terminate those containers, and at the same time, on the back end, the auto-scaling group will remove those EC2 instances that are not needed anymore because there is no need for that load. All those behavior or patterns, they happen automatically. So for us, it's just more a learning experience on observing how our platform is, I would say, elastic with load, with resource and cost. So it's been pretty, I would say, pretty stable so far. And the next one is health checks. So health checks is, we have standards in terms of health checks. When a container comes online, we run some health checks. And we leverage console to do that for us. If a container is not returning healthy, what console will do, it will mark it as down, and then will notify Nginx and say, you're upstream now, you had 4 containers, 1 is down, there are 3. And on Nginx, to achieve this, instead of restarting it, we do a reload. Doing a restart on Nginx is much expensive than doing a reload, and if there is any configuration changes or issue, the reload will fail and will be notified that that specific reload on Nginx didn't go through. Then the last part is the task role, which is very important. Each of our teams, they have a specific role on AWS, which in this particular case, I will focus on the KMS. And with each role, we assign a KMS key. So if I'm a developer and I want to pass environmental variables in there and I want to encrypt them, we have a functionality on the tool that you can type the passwords on the YAML file, and when you call our tool will leverage your role, will call KMS and do an encryption on those values. And this happens automatically to the developer. The challenge there is we encrypt everything, but they don't have the permission to decrypt. So once those environmental variables for Docker are encrypted and are passed to the container, we have another tool inside the container which calls KMS and say, can you decrypt this specific password or this key for me using their key that is dedicated to them on KMS. So we have different keys, rotations on keys on KMS. We're planning on looking at HSM to switch the private keys to an appliance solution. Now what happens is once my YAML file is completed, we take that YAML file, we leverage Ruby, and we generate a CloudFormation template. And then we send the template to CloudFormation, and CloudFormation and the way the template is built provisions automatically all those resources on our SSDR platform. Everything happens automatically. As soon as a container or a service is created on the ECS, that service is reported to Nginx and upstream, and a virtual server on Nginx is dynamically added. And also, on the Route 53 part is the DNS record, as you've seen on the previous slide, is added automatically. So the developer is, has this abstraction, just a YAML definition, and they do not have to worry. With this process, we are able to deploy. The average on CloudFormation is less than 2 minutes per service. we can do almost 20 deployments per hour, per application, per team, independently. So udeploy plus SSDR enabled us to provide a self-service infrastructure, which is cost-effective, easy deployments, and repeatable processes. So thank you all for being here, and I hope everything was useful.